So this stuff here, so there's, I'm gonna start, I just organized this so it'll start at 5.1 and we'll just go through this in order. So this is, you gotta read the instructions and the text of the questions carefully here. It says that line CD, can everybody see this okay? Should I make it a little bigger? Is that okay? Come up if you need to, there's lots of empty space in the front. Line CD is the perpendicular bisector of segment AB. Now that's important. That's a word that needs to mean something to us. What does that mean if the line is the perpendicular bisector of the segment? There's two parts to that. What's it doing? Ruby. Okay, but now specifically, maybe. But we're not worried about the triangle for now. I want you to just say what it does to this segment. So it cuts it in half, right? So it intersects it at its midpoint. So how could I add some marks on the drawing that say that part of it? That it bisects the segment. Okay, so we could, everybody agree if I put those congruence marks, that is our mathematical way of saying that that point is in the exact center and therefore it bisects the segment? That makes sense? Because this segment is congruent to this one, meaning they're equal lengths, right? Think what bisect means. Bisect means it cuts it in half or it cuts it into two equal or congruent pieces, right? Now, what about the perpendicular part? How would I say that on the drawing? Hannah, what do you think? How could I say the perpendicular part? If I'm talking about line CD is perpendicular to segment AB. What kind of mark could I put? Can you think of a mark you could put on the drawing to show that they're perpendicular? What kind of angle do perpendicular lines make? Right angle, good. So we can go like that, right? That summarizes everything that it tells us, correct? Okay, but there's something important that we know about a perpendicular bisector of a segment. This is the perpendicular bisector theorem from 5.1. Remember what this says. If a point, in this case C, lies on the perpendicular bisector of a segment, then it says something about that point. What's true about that point then? Everybody remember? Yeah, okay, so if a point lies on the perpendicular bisector of a segment, then it's equidistant from the endpoints of the segment, right? So we would know that this distance and this distance are equal. We could say that those segments are congruent, or we could just say that AC equals BC. Those distances are equal, right? So tell me then, I'm gonna put I'm gonna make a little drawing here. So let's say we've got E and F, and I'm gonna have a ray that goes like this. That's ray X, Y. And I'm going to make this point Z. Tell me something about point Z that we know here. Maybe, but there's no mark on there that tells me that. But I do know that it's on that. What can you tell me about ray XY? What is it? What is it, Mila? Say it again. It bisects perpendicularly, right? It is a perpendicular, that's our perpendicular symbol. Bisector of what? Segment EF, right? Okay, so then Z lies on that perpendicular bisector. So what must be true, Mallory, of Z? Tell me something about Z. If it's on this perpendicular bisector, what has to be true? What has to be true? Here's what we were just talking about, right? So the C, we said, was on the perpendicular bisector of AB, And so then it had to be equidistant, meaning same distance from the endpoints of the segment, right? So what's true here? Tell me something about Z. It's on the perpendicular bisector of the segment EF. Yeah, so Z is the same distance from what 2 points? E and F. Yeah, right? So we could say EZ is equal to, EZ is equal to FZ, or, I mean, whichever way you want to write those segments. ZE and ZF could also work. Make sense? Okay, that's it. That's the perpendicular bisector theorem. Okay, so then what would we write here? Write a relationship between AD, well, that's the relationship we know. What's the relationship between AD and CD? Or is there any?
No.
Not really, right? There's no reason for there to be a relationship. And as proof of that, I should be able to take this point C and I could drag it up this way and make this triangle taller and skinnier, or push it down this way and make it shorter and, right? And kind of a squat little triangle. But either way, it's still, C is just a point on this perpendicular bisector, but AD would stay the same, right? Does that make sense?
So is there a need to go through all that? I mean, I can just look at that and say.
Yeah, you probably can't, right? You probably can. I mean, it might look, it might even look like, what if C were right there, so it looked like they were congruent? That's just an accident, right? Because there's no inherent connection between AD and CD, right? So that answer would be NA. Does that make sense? There is no relationship there. Okay? Okay, same kind of thing. What about AC and AB? Any relationship there? You know, once again, I should be able to just take this point C and move it around, right? What if I moved point C down to here instead? Whoops. If I move point C down to there, it's gonna change the triangle so it looks like that. But, so AC changed, didn't it? But AB stayed the same. So they can't be related. If they were related, they both would have had to change by the same amount, right? Does that make sense? It's NA. Okay? Let me go back one real quick. What if they had asked about what if they'd asked about different segments? What if they had asked about, let's just say they had asked about AC and BC, those distances. What would that have been? They would have been equal, or congruent, right? The distances would have been equal. Segments would have been congruent, but they're asking for a relationship between the distances. And so the distances would have been the length, or distances are lengths. The length of that segment equals the length of segment BC. And once again, that's because now if I move C, if I move it down to here, well, look what happens. AC and BC both change, so they stay the same length, right? You see that? Regardless of where I put C, those distances are always going to be the same, right? Okay. What if they asked about AD and BD? What if the question was about AD and, BD? Yeah, they're equal, aren't they? Because this is a perpendicular bisector, so I know those segments are congruent. Once again, if I change the location of C, those still stay equal, don't they? Right? All right. Yep, yeah, we're going to go through everything. We'll go through all the important ones. So we'll just do one of these. These aren't quite as big a deal. This is the angle bisector thing, right? So let's just think back. This isn't as important in geometry as the perpendicular bisector. Remember what this said. If a ray or a line, or it could be anything, if ray BD is a bisector of angle ABC, so then how could I write that in here? What are the marks, the congruence marks I would have to add to show that? If it's bisecting the big angle, what does it do to the angle? Cuts it into two congruent pieces, right? So I could say that that angle and that angle are congruent. Make sense? Okay, so what happens? What's the consequence of that? If ray BD is a bisector of the big angle ABC, then any point on the ray, on the angle bisector, is equidistant from the two sides of the angle, right? So that would tell me that this distance and that distance have to be congruent, right? When we talk about how far this point is from the ray up here that forms the side of the angle, we're talking about a perpendicular distance because that's the shortest distance, right? So that would have to be true. So what's the relationship between, what if it asked, what's the relationship between AD and CD? Well, then we would just say that AD equals CD, right? It doesn't matter where we put point D. If we slide it back this way, well, that's okay. Then point A would slide back that way. And so would point C, right? And those would still be congruent, wouldn't it? What does it say about the length of AB and AD? Well, what do you think? Yeah, there's no relationship there, is there? Right? Okay. Make sense? Okay. These are the ones they're asking about right there. AD and CD. Those are the ones that would always be equal with the angle bisector theorem. Okay, moving on. 5.4, this is mid-segment theorem stuff, right? So a lot of stuff with this, but it's pretty simple. The relationship's not that big a deal. Quick review, what this is saying is if we've got this big triangle ABC where D, E, and F are the midpoints of the sides, right? Now, what do we call the segment connecting two midpoints of a triangle? What do we call that? Remember, Vanessa, what we call that? The segment connecting the midpoints of a, what is it? Remember? If this stuff isn't just jumping out at you, there might be a lot of people, you definitely want to take a look back at, maybe just look at the textbook. You have to read the whole thing, but look through the boxes, look at the definitions. It's called a mid-segment, right? So DF, let's take this one for example. Which one are we looking at? DF, yeah. So DF, segment DF, is a mid-segment. There are three possible mid-segments, aren't there? Right? But this is one of them. Now, what does the mid-segment theorem tell us? There's two important things that are always true about any mid-segment. Tell me one thing that's true about segment DF. What's one thing? Sam, what's one thing that's true about segment DF?
It's parallel to segment BDC.
Okay, good. It's parallel to the other side, right? This is, the mid-segment includes midpoints D and F. Well, the side through the third midpoint would be side BC. It's got to be parallel to that one, okay? It tells us something else. What else does it tell us? Ruby, what else does it tell us?
Point of A and C.
Say it again.
Is the point of A and C.
Well, yeah, F is the midpoint of A and C, and D is the midpoint of AB. They gave us that stuff. Good. But there's one more thing about that mid-segment. It's parallel to segment BC. What's another relationship between those two things? How about the lengths of the segments? What's the relationship between the length of the mid-segment and the length of the side? It's half. Yeah, exactly. DF is half as long as BC. And here's a better way to look at that. this mid-segment is congruent to either of the two pieces that are cut in half by the midpoint of the other side. Does that make sense? So DF is congruent to BE and EC, and so therefore BC is twice as long as DF, because it's equal to 2 of that segment essentially, right? That's it. Those are the two things that are always true about a midsegment. That's the midsegment theorem, section 5.4. If you want to just review that
I
briefly.
didn't do that. I didn't do that.
Say it again.
I didn't do that.
Okay, so how do we enter this? Yeah. So they're asking us here, segment. Now, what does that say right there? That's math for saying what? Segment DF. So are they looking for, is parallel to, are they looking for a number answer here or a thing? A thing, right. Because this is a thing. This is not a measurement. This is a thing. It's a segment. It's something we would have to draw, right? So what's the answer going to be then? Segment DF is parallel to segment BC, exactly. So how do I do that in Moodle? Segment, no spaces, then in parentheses, BC. That would work. What's another answer that would work? Not line. Segment, side BC would work. What's another thing that would work? Segment, what's a different segment that would work? DE would work. Segment CB, any of those would work. But probably the best one is just segment BC, right? But they all would work. They'd all give you credit, okay? Oops. Same kind of thing. Just slightly different question though. This is asking for a different type of answer here.
Yeah, this is what I'm talking about. Like,
Okay.
I get this and I have no idea.
Okay, let's look at this. So same kind of deal. We know that we've got triangle MNO and X, Y, and Z are midpoints, right? So they're telling us a couple things here. Let's kind of color code this. So XY, which is this guy right here, is equal to X plus 7. MO, which we'll do color red, is equal to 5x minus 1. Okay, we're trying to solve for the length of xy, right? Now, what's our strategy going to be? How are we going to solve for the length of xy? Alexi, what do you think? How could we do that? Just generally speaking, I don't want the specifics yet, but what's our approach, our strategy?
Well, x plus 7 is equal to 5x.
Okay, so in other words, we could set up an equation, right, that we could use to solve for the variable x. Once I solve for the variable x, what could I do with that? Carrie, what could I do with that? If I knew that x equaled 10, for example, what could I do with that?
Combine my terms.
Well, okay, I could, but say I've already done all that stuff and I found the value of x. How could I go back and find the length of xy if I knew what x was? Plug it in, exactly, right? So there's our strategy. We've got to come up with an equation. We have to use our geometry relationship to set up an algebra equation that we can solve for x and then plug it back in to get the answer, right? Okay, Gina, what's going to be, let's set up that geometry relationship. What's the relationship between the length of the blue segment and the red segment?
Would it be x plus 7 plus x plus 7 equals 5x minus 1?
Very good. So two of the blue ones, 2 times the quantity x plus 7 equals 5x minus 1. Gina just added them separately, which is fine, but we could also, if we wanted to, we could just say that like this, right? We could say 5x minus 1, the long segment, equals 2 times the length of the short segment, right? Same thing. Okay, and then what do I do? Algebra is not so bad here. What do I do to this algebraically? So I'm going to distribute the 2 and get 5x minus 1 equals what?
2x plus 14.
Okay, so Ahmad, what do I do next then?
You combine like terms, so you get plus 1. So,
Okay, so let's focus. You're right. But start with the variables. Which direction do I push the variables? To the
left.
Left, good. So I'm going to subtract 2x from both sides, which is going to cancel the variables from the right. I want to push the numbers the other way, so you already told me
Yeah, to the right.
Add 1, good. Now look what happens, so the numbers cancel on one side, variables on the other. 5x minus 2x is,
3x.
so what's x?
5.
Yeah, if I divide both sides by 3, x equals 5, so I'm trying to find the length of xy, so what do? Plug it back in. 5 plus 7 is 12, right?
Which equation do you plug it back into?
Well, it wants the length of xy, so I'd go back up to the expression for xy. Okay? Okay, make sense? Okay, we're getting there. Okay, what about this one here? Let's look at this. Now, remember, what are you gonna be doing on your notebooks or on your scratch paper when you're taking this test or you're doing the homework? Drawing these things, right? Writing on the pictures, you're adding stuff. So they're telling us some things here that we can write in. The measure of angle L is 40 degrees. They're telling us that JK is perpendicular to KL, okay? And they're also telling us that R and T and S are the midpoints of the sides of the big triangle. So they want to know what's the measure of angle JTR. So this is the one we're looking for right here, right? JTR. So how could I do that? What do you think?
It's corresponding with 40.
It is. You're right. How do we know that? So what could I do here? Do you see, if this is 40 degrees, can I find, I've got to find maybe some relationship between angles here. Can I see a place where I could create two parallel lines cut by a transversal?
Yes.
What do you think? So I've got this guy right here, right? Well, what if I were to, I know that this is a mid-segment, right? That's a mid-segment, so it's got to be parallel to the other side, correct? So if I were to extend those, aren't those just two parallel lines? Right, does that make sense? Because the mid-segment is parallel to the other side, right? So then this becomes like a transversal, doesn't it? So if I've got two parallel lines cut by a transversal and we're looking for this angle right here,
Can't RS too?
say it again? Yeah, RS could be too, that's right. Either way is fine, yeah. Except RS might not be as good a choice because this angle isn't connected to, this angle and this angle aren't connected to the same transversal of these two lines. You see what I'm saying? So the green, if I make the green lines the parallel lines and the orange line the transversal, well then the benefit of that is this is the line we're looking for. See what I'm saying? So that angle and the one that we're given have a relationship based on the green parallel lines and the orange transversal. What is that relationship? They're corresponding, aren't they? That's corresponding to that, and so what do we know? They're equal. They're congruent, so their measures are equal, right? So what's the answer? 40. Yeah. Make sense? Okay. So though, you gotta draw these on paper and look for those parallel lines and transversals and all that kind of stuff. Okay, one more of these. This time, what's it telling us? We want the relationship between AB and EF. We gotta find the length of EF. So what if they're telling me that AB is 30 and they want the length of EF? What's the length of EF gonna be? It's gotta be 15 because it's a mid-segment, right? Yeah. Okay. And they're asking for a number this time, aren't they? Not a thing, they're asking for a length or a distance. Okay, moving on to 5.5. enter the lengths of the three sides of a triangle that would build an isosceles triangle. Okay, so what does it mean to be isosceles?
Two sides.
Yeah, at least two sides are the same, aren't they? So how can I start with this then? Okay, give me two same sides, Gary. 9 and 9. Okay, so all they want is these separated with commas. So we've got side 9, and now I need to pick a third side. So what if I pick like 20? Does that work?
No.
Doesn't work.
How do you know what numbers work?
How do we know what numbers work?
Plus, if you have to add up to something number like bigger and not.
Yeah, good. Okay, any two sides, the lengths of any two sides have to add up to more than the other side, right?
So it could be 17.
So it could be 17. 17 would work because then the smaller two, 9 plus 9, adds up to more than 17, right? Could be 17, could be 15, could be 10, could be 8 for that matter, right? Because then 8 and 9 adds up to more than 9. See what I'm saying? Okay? Any of those would work. Okay, so this is a little tougher. Now, this is not on the test. I didn't put one of these on the test, but I want you to do some of these on the assignment. How do we deal with something like this? Build a right scalene triangle. Actually, I'm going to make it a little different. Instead of a right scalene triangle, let's make it not a right, let's make it an acute. An acute scalene triangle. How would I do that? What does scalene mean? No sides are the same. So where do I start? Pick two sides. Yeah, pick two sides. Okay, 2 and 4 I could. Now I'm going to make a recommendation. If we don't want to use decimals, let's maybe pick a little bit bigger numbers. Like something maybe like that, right? Where they're bigger numbers so that the reason I'm doing that is so then that I'm not stuck with getting an answer that is like has to be a decimal. You know what I mean? So if we pick 17 and 11, we need to pick another number that's going to fit with those two and build an acute triangle, right? So here's a way to approach that. Well, how would I build the third side that would make it a right triangle? If I wanted to make this a right triangle, so that's 17 and that's 11, how would I find the length of the hypotenuse? Call it x. What's the relationship between the lengths of the sides in a right triangle? One of the most famous math. What is it again? Well, okay, but what is it exactly? A squared plus b squared equals c squared. What theorem is that? Pythagorean theorem, right? So the lengths, the squares of the legs have to add up to the square of the hypotenuse, right? So we would know then that x squared would just equal 11 squared plus 17 squared. So whatever that number is, x would just equal its square root, right? Let's see, that guy. Oops. That guy. So x is just the square root of 11 squared plus 17 squared. Well, that's a calculator issue. I mean, no one knows what that is, but that's okay. We'll plug it in the calculator. What does that give me? 289, 121, so 410, so it's going to be about 20 point something. So if I want this to be, acute, let's see exactly what it is.
Wait, I thought we were on the right.
What's that?
So I thought we were on the right. Are we just jumping back and forth? Someone speak up, someone say something.
What, on the right, what do you mean? A squared plus b squared equals c squared, right? For the right, exactly. So we're going to find out what the length of the hypotenuse would be for a right triangle. We don't want a right triangle, but we got to know what it's going to be. So let's find out. So square root of 11 squared plus 17 squared is, I think 410, let's see. Square root of 410. Which is, yeah, 20 point, so it's 20.24. So if that's the length of the right triangle. To make this an acute triangle, what would we have to do to this rubber band to make this angle less than 90? Because that's the goal, right? If it's an acute triangle, we need to make this smaller than 90. If it was obtuse, we'd have to make it bigger. So what would we need to do to the length of the other side? This is the exact length it would have to be to make it a right triangle. Make it smaller. So give me an example of one that would work. 19 or 20 or 18, right? Does that make sense? So that's the threshold. That's the divider between acute and obtuse. So we would just pick one like 19. That would work. Yes, ma'am. Yeah. Okay, so what about this one here? Now this, I want you to pay really close attention to this because this is really important. Not super hard, but there's something you gotta be careful of here. So it says, write a compound inequality representing the possible values for x, y in triangle XYZ. Actually, this isn't the one I was thinking of, it's still an important one. So they give us two sides of this. They give us XZ and YZ. So we want the missing side, which is XY. Now there's gotta be two things that could happen here. How would I find the smallest possible value of XY? What do you think? Abel, any ideas? I want to find the smallest possible value of XY. Could it be 4?
Yes.
XY could be 4? You sure? What would happen if I chose XY to be 4? Would those sides make a triangle? Why or why not? What's the problem with that? They don't obey the triangle inequality. If I made it 4, then the smallest two sides, 10 plus 4, aren't more than the other side, right? Does that make sense? So how are we going to figure out what the smallest value would be? Well, if XY is not the biggest side in the triangle, which one is? XZ is, right? Good. So we would know that whatever XY is going to be, one thing that has to be true, XY plus 10, the other small side, has to be greater than 15, right? Does that make sense? That has to be true. Well, what's the other possibility? That XY is big, but it can't be 1,000, right? It can't be too big. So what if it is the biggest side? What has to be true if it's the biggest side? Then the other two have to be greater than it, right? Good, so we could say then also 10 plus 15 has to be greater than XY. Those two things have to be true at the same time. So what happens if I solve this one? What do I have to do to get the XY by itself? Subtract 10. So one thing that has to be true is XY has to be greater than 5. What do I do here? Just combine them, right? So I also know that 25 has to be greater than XY, or XY has to be less than 25. Well, how do I say both of those things at the same time? Compound inequality. So now I put XY in the middle, and I say it's got to be greater than the small number on the left and less than the big number on the right. That's it. Okay? Make sense? Questions on that? What would I do here? I want to pick the sets of the lengths of the sides that would form a triangle. What am I looking for?
Two sets that are like really greater than the
Yeah.
side.
Okay, good. So Carrie, does the top one work?
Nope.
Nope, because 4 plus 3 is less than 9. Braden, does this one work? 6, 7, and 13. No, because 6 plus 7 is equal to, but not greater than 13. So neither of those work. Does the next one work? It does. Good. So that works. How about the next one? Nope. 8 plus 4 is not greater than 12. Next one.
Yeah.
6 plus 10, or 6, now how would I do this one? 6 plus 6 are the two smaller ones are greater than 10, so that does work. How about this one? The two small ones,
Yeah.
9 plus 12, nope, 21 is not more than 22, so that's it, right? Okay. Okay, so still 5, 5. What's the longest side of the triangle? How do we know? Good, because big angles look at long sides. Small angles look at short sides, right? That's how we order it. So we know two of these angles. It tells us measure of angle U is 62 degrees, measure of angle M is 36 degrees. I would have to know the length of P. How would I find it? Sierra, how could I find that? What's the length? How could I find the missing side length? I know two of the three, 62 and 36. Okay, good. They have to add 180, don't they? So combined 62 and 36 is 98. So 180 minus 98 is what? 72? Is that right? 82. So this guy's 82 degrees. Okay, so then which is the longest side? Yeah, UM. Good. So that guy. Right? Okay. Okay, what's the largest angle? They give us all three of these side lengths. This is pretty easy ones. They give you everything you need. 22, dB is 23, ED is 8. What's the biggest angle? E, because it's opposite the longest side. Okay, all right, so this is, we're out here at 9:35?
Yeah.
Okay, let me tell you what, let's leave it there. I'm gonna take roll. Tomorrow we'll finish up these last few problems. And then how about if we go ahead, I was gonna test tomorrow, but how about if we just test Thursday instead? Does that sound good?